Okay, so let's find the equation of the tangent line at x equals 1 for this equation, and then we're going to do a slightly more complicated problem to learn how to do this for any problem that you're given. Okay, so starting with this equation, it's a relatively simple one, so let's go ahead and graph it so we can visualize some of this and understand kind of conceptually what's going on. So I'm going to graph the graph of y equals x squared, and I'm really bad with graphs, so bear with me. See? Okay, so the graph of y equals x squared looks something like this. Okay, so let's talk about what this is asking us. When we talk about a tangent line at a certain point, we're talking about the line that goes just through that one point and doesn't touch anywhere else on the graph. So if I were to zoom in on that part of the graph, like if I were to zoom in right here, what it would look like is, let's say, like this is the very zoomed in part of it, and this is the point. Then this blue line is not touching anything except that point. There's like one point on the line that it's touching. And so that's what a tangent line is. And so there's plenty of, you can find the tangent lines of any x value along this graph, but we want a very specific one. They're asking for the one at x equals 1, which is right here. So they want to find the line, the equation of the line tangent to this point. So I'm going to go ahead and just kind of eyeball what that would look like. It would look probably something like this if I just had to eyeball it. And so we are trying to find the equation, want to find equation of this blue line. Okay, well, let's think about what information the problem has given us. It's given us that x equals 1, so we know here x equals 1, and we can't always graph these equations, but when we're given the x value and the equation, we can find the y value. We just have to plug it in, right? So let's go ahead and plug in 1 to get that y value of this point. F of 1 equals 1 squared, which just equals 1. So this information has just given us a point, that red point, 1, 1 on the graph. So the point 1, 1, which is right here, which we saw from the graph. But what's really important about this point is that, yes, it's on the graph, but it's also on the tangent line. So this point is on the tangent line that we want the equation of. So we're one step closer to finding the equation of this line. Well, what else can we use? If we just have one point, what we need to find is the slope of this line, and then we can determine the actual equation of the line. Well, how do we find the slope of the tangent line? That's where the derivative comes in, and that's the whole beauty of the derivative, is with very minimal information, we can actually determine the slope of this blue line. So we're going to take this equation, and let's take the derivative and see what it gives us. So the derivative of this equation is 2x. Now what this equation tells us is the slope of the tangent line at any x that we want. So if we wanted one where the x is -2, if we wanted this one, we could get that slope. We just had to plug it in right here. We just had to plug in -2, and we'd get the slope of this line. But we want the slope of this blue line right here, which is at x equals 1. So let's go ahead and plug in 1 for x in the derivative. So equals. So f prime of 1 is going to equal 2 times 1, which just equals 2. So what this is telling us is the slope of that blue line that we did at x equals 1, the slope should equal 2. Well, even though I eyeballed it, let's take a look and see, does it look like it's 2? Well, there looks like there's like a point right there, and there's that red point we talked about, and it's up. We're going to do rise over run, so it goes up 1, 2 over 1. That's 2 over 1, and that slope is 2. Let's try it again. Up 1, 2 over 1. Yes, so the slope, even though I eyeballed it, we can see clearly the slope of that line is 2. And we were able to figure that out with just the derivative. So for more complicated equations that you can't graph, that's where the derivative is so helpful and so powerful. Great, so now we have a point and a slope, but we still want to find the equation of that blue line. So what we're going to use next is a handy-dandy equation called the point-slope formula, which lets you take a point and a slope, and it'll help you find the equation of a line. And it looks like this. It's y minus y1 over x minus x1 equals m. And all this means y1 and x1, this is just any point on the line. And m, it equals our slope. So this slope here, this 2, is also our m. So we already found m right here. And if you remember, we found a point on the tangent line as well, which is 1, 1. And so this is x1 and y1. So we have everything we need to plug and chug into this equation and find the slope of that line. So let's go ahead and do that. It's going to look something like this. Y minus 1 over x minus 1 equals 2. So I'm going to multiply by x minus 1 on both sides. We're going to get y minus 1, and then equals 2 times x minus 1, and then we're going to distribute. So y minus 1 equals 2x minus 2. And then we're going to add 1 to both sides. So we get y equals 2x minus 1. And so this, finally, is the equation of that blue line that we wanted to find earlier. And so if you remember, this is now in our y equals mx plus b formula, and the b is our y-intercept. So if we got this correct, then our graph, or the tangent line, the blue line, should intersect the y-axis at -1. Let's check. And it does, at -1. So we were able to successfully find the equation of the tangent line at x equals 1. Okay, so let's try a slightly more difficult example. In this example, it's a little bit harder to graph or visualize what the graph would look like. So we're going to just base everything off of the information we get from the problem. So let's remember the two things we need to find the equation of the tangent line. The first thing we need is a point on the line. And the second thing we need is the slope. And with those two parts, we can find the equation of any line, right? And remember that the tangent line and the graph will share that one point where the line is tangent. So by finding a point, the point on the original graph, in the original equation at x equals 1, we also find a point on the tangent line. So let's go ahead and do that. And let's plug in 1 into our original equation. F of 1, this is before any derivatives happen. We just want to find the point. It's going to equal 3 times 1 cubed minus 4 times 1 cubed. 4 times 1 squared plus 7 times 1. And this is just going to give us 3 minus 4 plus 7, which is just 6. So now we know that we have a point on our graph. And on our tangent line. Perfect. So now we want the slope, and this is where the derivative comes in. So we're going to take this equation, we're going to take the derivative, and you have prime of x equals, this is 9x minus 8x plus 7. Perfect. Now we have an equation from the derivative. We have an equation that'll give us the slope of the tangent line at any x that we want. But remember, we have a specific x in mind, and in this example, it's 1. Remember, it's one from the problem. Okay, so let's plug in 1. From a 1 equals 9 times 1 minus 8 times 1 plus 7, which equals 9 minus 8 plus 7, which, if I can do my math properly, does equal 8 here. So now we know that 8 is our slope, aka our m value that we're going to use in our handy-dandy point-slope formula, which goes like this. Y minus y1 over x minus x1 equals m. And again, remember this y1, x1 is just right here. It's that 1/6 that we found, and our m is just our slope that we found. So if we do some plugging and checking, we get y minus y1, which is 6, over x minus x1, which is 1, equals 8, our slope. And now we're going to multiply both sides by x minus 1. And we're going to get that y minus 6 equals 8x minus 8. Distribute that out, and then we're going to add 6 to both sides. And we finally get that y equals 8x minus 2. And that is our final answer. And this is our equation of the tangent line at x equals 1 for this original equation up here. So I hope this helped you understand what it means to find the equation of the tangent line and how we find it from just this very minimal information given in the problem. And hopefully this demonstrated how powerful derivatives can be and why they're so important in math and in calculus and all the cool things that you can do with them.